removed some of the stuff last time and that stuff.
Okay, so I want to talk about the homework tomorrow, and part of the homework is PA3. So, so can you close your computer? And then you can get back to it in a minute. Close the computer.
By closing is a fatal pause.
Close. They're all. Everybody's working so hard. It's great. Close. One more. Two more.
Wait,
Three.
darn. I can't
I
close
wish
it.
my daughter would do this so easily.
What do I do?
Stop playing that game. Come for dinner. She goes, just a minute. Just a minute. I gotta finish this level.
Yes, sir.
Yeah.
5 minutes.
Okay, so for I want to talk about PA3 briefly. We're going to talk about it more tomorrow. But the idea here is to give you some experience working with a simple physics simulator, which is a part of a lot of games, and to get you thinking about it. So it'll be good for this group, but others, you might be able to make up real physics simulator applications. And in any case, it's actually a really good idea of separating the model from the view and the controller, which you should do everywhere. You should always have the model, as much as you can, separate the model and the view and the controller. So let me first explain what this little game is. The little game is played in some space. I guess it's actually an infinite space, but it has a ground, so nothing happens below the ground. And a level consists of a bunch of squares that are static and not physically balanced. So it's like super, super glue, right? So there's really tough glue, so they can be in all kinds of weird angles. And then one of them is, one or more are targets, red boxes, which you're trying to hit.
Angry birds.
And then you have little discs, some number of discs. No bird faces on them though. And you grab them by going like this and flicking them.
Yeah.
Flick them up, right? And they should be, so you flick it, the flick from when you put your finger down to let go, it'll calculate the distance and the time and the velocity. And then use just a simple gravity simulation to track it. Ding, 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 ding. It hits this, yes, you won. But if you miss, it might land right here, it might touch this. If it touches one of these static things, it stops and becomes static. Right? Static. So you throw another one, flick, and it comes up here and it lands there. Oh, dang.
Oh, no.
Static. Now you're in trouble. Right? So then you flick this other one way up, and it comes down, boom, and you win.
What?
Wow.
Now it got a little smaller all of a sudden.
Yeah, well, okay, so.
Power up.
Okay, so this is the model. So it's a simple gravity, no wind resistance, none of that kind of stuff. And then you got squares, all the same size, discs, all the same size. And some of these discs down here that you haven't used yet are dynamic, but once they hit this one, the game, they go to the next level, or this one, they become static. And you can only throw one disc at a time. These are all assumptions to make it simpler.
Cool.
And it would actually be cooler, and that's part of the idea, is for having one of the assignments for tonight is to think about how to extend it in ways that might be hard to implement, but would be cooler. Like you could have bounce, throw multiple ones up, and have them bounce in the air against each other. But then you have to figure out the physics of collision.
Let's do it.
Right? Yes?
Working on it.
So it's like it does a velocity from the ground,
Yeah,
not
we're just gonna make
acceleration,
this.
right?
What's that?
Like it comes off the ground
Yeah.
at constant.
At that velocity, whenever you flick it, it uses the distance traveled from the finger down to finger up, and the time to calculate the velocity as it was shot from this point with that velocity at that. Yeah. Okay?
Yeah.
So the question is, so the homework is, here's a description of it, and the rules. Basically keep it easy. And you're supposed to write the model for that. The model for, not the view, not an Android application, just a Java application that will tell you, that will represent the state of this situation. So the idea is at any point you should be able to query it and say, okay, at this time, where is everything? Right? And it will give you, I mean, there are lots of ways to do it. Partly, I don't want to tell you too much because I want you to think about it. Right? I want you to think about how you would represent the model part of this without the view. Because you could do this like in 3D with Python, some kind of 3D view with cameras moving around, or you could do it on the Android phone, or there's all kinds of different views you could have for it. But forget about that and just imagine the model. So you have to have some way of adding squares to it, initializing it. You have to have ways of setting velocities to something. You have to have a way of saying start, and then querying it at different times. Where is it at this time? So, yes?
So if we only have to write the model, it means we don't deal with controllers, so no.
No controllers, no, there's no
events,
flicking. But you do need to write. You do need to write some tests. So you think, how would you test this model?
Okay.
Right? And the easy way to test, I think, is to just have a little read eval print loop that prints the state every 10th of a second, and let's ask you if you want to do something. Do you want to change the velocity of some object? And it shows you where all the objects are, something like that.
Can you give a hint as to how many classes they will end up designing more or less?
I did it. Took me an hour after 3 glasses of wine, actually. So 1 hour and 15 minutes. Huh?
You try that speed you up or slow you down, the wine?
I don't know.
Is there a reason why you drink wine?
So you get a
It's good for your. It's supposed to help you live
But I
longer.
mean, when you're programming, because I've talked to other computer science professors.
They drink a little wine when they program.
Yeah.
Yeah.
I won't say that.
Here and program.
Yeah.
Well, I don't drink wine. I program in the morning and I don't drink wine. It's only like, no, I drink wine actually strictly for my health. I drink,
Alcoholic wine.
yeah, usually only 2 glasses. But that was on the weekend, so you know. But strictly for health, I don't do it for any other reason. Okay, so is this clear? Roughly, I mean, there's a lot of, so there were some complaints about having to read my code and extend it. Right, so there's nothing there, you got it all yourself. The game, I think it's pretty clear what the game is. Any questions about how you play the game? Yeah?
So, you explained it that the user uses his finger or whatever
Yeah.
to set the velocity or whatever, so how is that going to be
No,
set?
so just ignore that part. That was just to give you a sense of one way
So
that you
this
could
is
use
just
this model for a
strictly
game.
text-based?
You could have another model for the game that would actually have these things down here would be little soccer balls on the floor with a GPS in them or some converter. You kick them, and that would give the velocity.
So you could imagine
Right, so-
writing, you could imagine writing the Android code, which you're not going to measure the flick, determine that it went 1 inch at this speed, and those are the inputs into your model.
Yep.
And that model is
That's-
going to be your.
Or you could use a Wii controller. Have a Wii controller that you push the button and throw, and that gets translated into the velocity for the
Okay,
next
so it's
ball.
never going to be.
So it doesn't matter. The flick was
Yeah,
just
so
to
how
get
are
you
you gonna
thinking
test
about
it?
how one way to do it. But that's the view. That's the controller. That's the controller part.
Yeah.
The view part is just draw the screen after 0.3 of a second. Let me see what it looks like. Where is everything? So
At any point, you should be able to grab a disc or something in the air if you're doing
so
it.
that's so if you do it with a little loop, you should have some command that says, grab disk, and it'll just stop the disk right there, and then you can move the disk back and forth. I thought it could be interesting to have something where you have a big block here and you have to like toss it up and catch it, and then move it over here and then toss it up and catch it. Also, it's just an interesting extra feature to add. Yeah.
So we have to draw everything? Like
No, draw nothing.
No drawings?
No
just the
drawing.
results.
That's the point. All you're doing is the model,
Yeah, I mean, okay.
just the
So,
model.
Yeah, we give like a velocity and angle, let's say, and
Yep.
the results.
Yep. So the idea is just, you have to have something which will add a block and say where the block is, to decide what the coordinate system is. You have to have something to add add disks. You have to have something which says give a velocity to a disk.
Right.
And then you have to have something that says where is, in fact, maybe you need IDs for the disk. You have to think about how to do that. and ask where is disk number 1 at time. Yeah. Or you say, the other thing you can say is update. Probably it's better to do this. Update the model, and you give it how long has passed since the last update. That's the way these things usually work. So let me just add that in. So there will be a time, a time field. Time, right? And then you'll have something which says update the model 100 milliseconds later.
So it's almost like
And it'll move things around.
we're just like, you're gonna make a view, and we're gonna have to like plug ours into your view eventually. That's like the conceit of this.
Yeah.
Okay.
Yeah.
Okay, so to the question, how many models did you end up with?
3.
Okay. The reason I ask is, a solution that has everything in one model, in one class, is not a good solution. You're gonna have multiple classes representing things would have some meaning in the context of the scale.
And I should have had 4.
Yeah, I'm just saying, I just wanna make sure, because you could do this in one class, but that would be a C-level.
So try to make them, real
Meaningful.
Make them really meaningful and elegant. The
Yeah.
code should be elegant. You look at it and go, wow.
Well
it's
thought
so
out.
clear.
Yeah.
Yeah.
How many weeks do we have for that?
Say what?
You did an hour. It's an hour. It's an
Now-
hour job. Really, the hard part is just thinking about it.
And that was the wine.
And that was the
You
wine.
didn't make the Java doc?
Huh?
That's true. How long would it take?
I didn't do the Java doc. Maybe I did.
That's good for the
Yes.
goose.
The physics aspect?
Yeah.
Are we should we just like look online or something?
Yeah, look online. It's a real simple.
It's
Iso
just
physics.
general Newtonian,
Yeah.
what's it called? Pneumatics.
Yeah.
Yeah, the Newton's
So
laws.
I can get that online?
Yeah, I
Yeah.
can send you guys all a link to it.
Do it. Do it.
Extra credit if you do, general relativity.
Can the thing go into orbit?
If you get it over terminal velocity,
Yeah.
or whatever, not terminal, to,
Well, actually, that's
exit velocity.
you don't even have to do
Orbit,
that,
comes
right?
back.
That's that's a whole different game. I mean, I leave it up to your imagination from there.
But they give me a
But you
special-
could. It doesn't have to fit on the screen. You could track the motion. You could say the view could say it's infinite space. The view will just be centered on wherever the disk is. And if the disk gets up to the end, the view will jump, or however you want to do it. That's a different. So don't worry. Don't be confined to borders. The only border is here, which is white 0. If there's a ground, things shouldn't be happening underground. And actually, it's okay for this model to have them embed themselves partially in it. Don't worry about solving exactly the collision equations so that you get it to just barely touches. When you do it, you'll find you'll be incrementing the time, and one will collide and be slightly inside the other, and just leave them like that. Just imagine it like balls getting thrown by a tornado. Smash! They get stuck in the wall. Yeah.
Dimensions and constants like gravity.
Like meters.
Meters?
Make it, use the meters. Kilograms, newtons, that kind of stuff.
Not the line.
No foot-pounds. Okay?
Alright.
And you've got a week for this, we can talk about it.
About fist
You know,
pounds.
if there are other things that come up.
Wait, what is it that's due tomorrow?
So do tomorrow, let me show you. Ooh. That's over here actually. Tomorrow is 3 things, both 3 blog posts. One is MVC example, game name. So write a blog post describing the underlying model for some video computer phone game you're familiar with, Angry Birds or whatever. Explain how the view uses that model to generate the graphics on the screen, how the controller modifies the model based on user input. Be prepared to present your analysis in class. Does the model use some sort of simplified physics engine? If so, what are the rules for how objects interact? What kind of objects are supported? Comment on 3 other blog posts. So here I want you to be thinking, looking at a game and saying, what's the underlying model? What's the view? And how does it take input to control the model based on what I do?
So when you say game, you don't mean like Halo. You mean something like.
Well, Halo is
You
game,
can Halo.
isn't it? You can do Halo.
Well, the models are ridiculously complex.
Well, that's all right. You don't have to do it. I don't want all the detail,
I'll
but
do Halo.
you could.
Micro halo.
Can I
Yeah.
see Michael?
What's the basic?
Got a couple of
Play
pictures.
like 10 video games before I can decide.
I mean, if you don't know any games, then let me know. I can try to point you to another.
Just remember what you brought back.
Okay, so that's one. And here, when it says game name, I don't want to see GAME anywhere. It should be the actual name of whatever you're doing, Tetris. Or
What if
Angry
those
Birds.
letters are in my game
That's okay, if there's a game called Game Name, then you're okay, yeah?
Please name your blog posts, not blog 0, blog 1, blog 2.
Yeah,
Oh, yeah,
I
like
should
that.
name.
It's sticking to not doing Yeah, that.
Okay.
Started naming.
Okay, blog 2. Blog 2. So these shouldn't take too long. I think it's just really, I just want you to be thinking about it. Blog 2, PA3 extension, brief description. So give a brief description of it. Comment on 3 others. Describing some possible extensions for that game which would enhance the problem-solving attractiveness of the game. So games often are problem-solving with an attitude of fun. Is that what is it? Playfulness? So think about how you can make it, more fun. And the one idea I thought of was to have them have collision to allow things to bounce. But maybe there are other things you could do that would make it more fun. So that's it. Describe extension. Explain how this could be used to create more interesting levels.
I'm gonna make it rain.
What's that?
I'm gonna make it rain.
Rain? Yeah, you could have wind.
I don't want any more.
There's all kinds of things you could do. I don't actually want to throw out ideas, but so you can pick. And you don't have to implement it. I'm not going to say, okay, now homework is implement your idea. You don't have to do that. So you can be as crazy as you want. And then finally, there is a little bit of coding. Work through the introduction to the libgdx wiki pages here, and go through the example, read through them, and work through the example My First Triangle, which is a very cool, very simple little thing, which draws a triangle on the screen, but it also does it on Android. So it shows you first how to do a Java application as an Eclipse project, and then create a little 10-line Android application that links to that one, and basically takes that on the Android, and that's the libgdx model. So their model is you develop everything on, it's just a Java application, then you have a little teeny bit of splicing code that puts it onto the Android. And it's really good. It shows you how to link. Eclipse always says open other projects that are dependent on this one. This is how to do that dependence.
Is there any estimate time for that last bit?
This last one, I did in 20 minutes. With no wine though. I wasn't drinking.
What's your multiplier?
That's offensive.
Wine, 15.
Oh, I finished a bottle of wine. It took me about 3 or 4 minutes. Dare you try and beat me?
I just poured the wine on my keyboard.
Hey, what's your student's
What
multiplier?
wine was this?
What?
What wine was
Hey, what wine
this?
do you drink?
I buy the cheap $3 wine at Trader
$2
Joe's.
Chuck.
$3 Chuck now.
$3 Chuck on this list.
Yep.
Yes, West Coast.
We should,
Well,
we should have
statistically,
an
you
advertisement
can't tell the
campaign
difference
for them.
between
What's
cheap
that?
and
We should have an advertisement campaign for them.
Right.
You're not.
Well, the important thing with wine is like anyone can buy an expensive bottle, but if you can buy a cheap bottle that's good, then
And code after that.
yeah.
That's the important stuff.
That's right. That's not part of the assignment, especially if you're under 21.
If you're under 21, come see me.
Liability.
I don't think it was on the website either.
Okay, any questions on this? No? Okay, great.
Wait, Darren, what did
Thank
you
you
do?
so much.
Real quick.
Uh,